the curves a little bit. Let's reduce the color, the brightness. The brightness inside the brightness. You see that brightness? This is what confuses me all the time.
The latest enhanced image of interstellar object 3I Atlas did not arrive with the usual fanfare of a NASA press release or a university-led publication. Instead, it emerged from a long exposure capture by an independent astrophotographer, Ray's Astrophotography, before being subjected to an unconventional high-contrast forensic analysis. What this process allegedly revealed has ignited quiet debates among astronomers, data analysts, and space science communicators. A spiral-like rotational wave in the comet's inner core, two straight opposing jets extending above and below the nucleus, and a sharply defined halo boundary that appears more like engineering than physics. These claims, publicized through a media outlet rather than a research paper, have drawn attention because they fit into a larger, still unresolved narrative surrounding the nature of 3I Atlas, only the third confirmed interstellar object ever observed passing through our solar system, and perhaps the most visually complex. When the forensic passes were first applied, stripping color channels, isolating luminance, performing edge detection, and mapping wave patterns, analysts expected to reveal noise, not structure. Most processed images of cometary comet degrade into chaos when pushed beyond their natural contrast range. Dust grains distort into bloom artifacts, faint jets dissolve into static, and the nucleus becomes a blown-out blur. But in this case, the enhancements seem to carve order from the darkness. The spiral-like feature emerged repeatedly, not as a random distortion, but as a consistent curve that stayed coherent under multiple methods of brightness normalization. The axial jets remained unnervingly straight, almost symmetrical, refusing to spread outward the way natural outgassing plumes typically do. And the outer halo of the coma, instead of fading gradually into space, appeared sharply delineated, showing a boundary more abrupt than any standard comet imaging would predict. To those accustomed to planetary science datasets, these features raise legitimate questions. Spiral structures have been observed in comet before, usually caused by jets rotating along with the nucleus. But those spirals are diffuse, fuzzy, and unsteady. What the enhancement of 3I Atlas seems to reveal is something different. A pattern that looks stable, as if governed by a coherent rotational symmetry. Cometary jets can appear straight under certain conditions, such as when they originate from narrow vents in the nucleus. But their persistence across multiple filters in the enhanced image appears unusual, and the outer halo of the coma, instead of fading gradually into space, appeared sharply delineated, showing a boundary more abrupt than any standard comet imaging would predict. The broader scientific context makes these enhancements all the more provocative. 3I Atlas, discovered in July 2025, carries the same mathematical signature as its predecessors 1I Oumuamua and 2I Borisov, a hyperbolic orbit, an incoming trajectory unbound to the Sun, and a speed that confirms its origin beyond our star system. From the moment its interstellar identity was confirmed, observatories around the world began targeting it. Early spectroscopy revealed an abundance of carbon dioxide with a markedly higher CO2 to water ratio than that of many familiar comets. Its dust and gas composition, though generally comet-like, contained some anomalies that hinted at unfamiliar formation conditions. Polarimetric measurements showed an unusually deep negative polarization branch at small phase angles, a clue that its dust grains might differ significantly from those found in typical solar system comets. None of these observations suggested anything unnatural, but they did paint a picture of a comet formed in an environment quite unlike our own.
Adding to the intrigue were the large-scale jets observed by professional astronomers. Deep sky images taken by large aperture telescopes revealed two prominent anti-tail jets aimed toward the Sun, while the primary tail streamed millions of kilometers into space in the opposite direction. Astronomers noted that the structure of the jets was remarkable even before the forensic enhancements appeared online. Some describe them as broader, more energetic, or more sharply divided than average, though still compatible with natural comet behavior. If the forensic enhanced image indeed reveals more detail within the inner coma, the question becomes whether these patterns represent real physical features or artifacts of aggressive processing. The problem, as several analysts quietly acknowledged, is that forensic enhancement is a double-edged sword. Push an image too far, and the algorithm may begin drawing shapes that resemble order where none exists. Over-enhanced stars become crosses, noise becomes geometry, and the human mind fills in the rest. A spiral emerging from the contrast-stretched haze of a comet image is not proof of a spiral in the comet itself. Yet the article claims the structures survive repeated analytical techniques. Without the raw FITS files and a reproducible workflow, it is difficult for outside experts to confirm or refute the findings. And because NASA and major observatories have not publicly commented on these specific enhancements, the discussion remains suspended between genuine curiosity and scientific skepticism. Still, the timing of the enhancements touches a sensitive nerve. Public interest in interstellar objects has skyrocketed since Oumuamua's famously ambiguous nature. Its unconventional acceleration, its elongated shape, its lack of a detectable coma. That object spawned a wave of speculation ranging from hydrogen icebergs to alien probes. 2I Borisov, in contrast, behaved almost exactly like a conventional comet, offering comfort to those who prefer natural explanations. But 3I Atlas stands somewhere between them. More active than Oumuamua, but far less typical in its composition and jet structure than Borisov. When an interstellar visitor already known for its oddities suddenly reveals novel inner coma geometries under a forensic pass, it is natural for the public imagination to engage. Yet, imagination aside, the implications remain scientifically compelling. If the spiral pattern is real, it could suggest a nucleus rotating with a stability unusual for comets. If the axial jets are genuinely straight and symmetrical, they might indicate narrow, high-velocity vents unlike those observed in most solar system examples. If the halo is indeed sharply bounded, it could hint at an interaction between dust, gas, and radiation pressure not seen before. None of these interpretations require anything artificial, though they do suggest that 3I Atlas could represent a type of comet that forms under different physical and chemical conditions, perhaps around a cooler star, or in a region with higher background radiation, or with a distinct mixture of ices and minerals. Studying such objects deepens our understanding of how planetary systems across the galaxy may differ from our own. As discussions grow, some observers have pointed out another wrinkle. NASA's release of official 3I Atlas imagery has been slow, and their public statements have been more cautious than those made during the Borisov campaign. While this can be attributed to prioritization, the availability of data, or the compressed observation window the comet offers, it has also fueled speculation that the agency may be withholding higher resolution images that could confirm or deny the patterns seen in the enhanced frame. Historically, major institutions delay release only to ensure accuracy, not secrecy. But in the current climate, where interstellar objects capture global attention, silence tends to generate its own narrative. Meanwhile, astrophotographers and data scientists worldwide are now attempting their own versions of the forensic pass. The hope is that multiple, independent analyses of raw, long-exposure data will either validate the presence of the spiral and jets or expose them as processing artifacts. If the former occurs, a new frontier will open in the study of interstellar comets. If the latter, the episode will still have served a useful purpose by pushing the community toward greater methodological transparency in how images are processed and interpreted. What remains certain is that 3I Atlas has already earned its place as one of the most scientifically and visually intriguing objects of the decade. Its trajectory ensures it will soon fade from view, leaving behind only the data we managed to collect during its brief visit. Whether the spiral in the enhanced image represents a groundbreaking discovery or an illusion born of contrast algorithms, it has forced scientists to revisit assumptions about what these interstellar travelers might look like when observed up close. The comet's jets, composition, and polarization behavior already mark it as an outlier, and if further analyses confirm more structured geometry within its inner coma, the implications for comet formation theories could be profound. As we wait for new images to be released, the enhanced frame stands as both a curiosity and a challenge. It reminds us how much of the universe still lies outside our understanding, how easily the familiar can become foreign with a shift in perspective, and how each interstellar object that passes through our solar system carries a fragment of a distant world we may never see. 3I Atlas, with its spirals, jets, and enigmatic halo, is a messenger from a star system that evolved under conditions we can only infer. Whether its unusual features are real or imagined, they prompt a deeper question. How many other objects like this cross the galaxy unnoticed, and what secrets do they carry? The enhanced image is one frame in a much larger story, a reminder that every interstellar visitor is not only a scientific opportunity, but also a hint of the extraordinary diversity that lies scattered between the stars. If future analyses confirm the structures suggested by the forensic processing, 3I Atlas may become the first interstellar comet to exhibit organized inner coma geometry unlike anything documented before. If the findings are disproven, they will still underscore the need to approach extraterrestrial data with both imagination and rigor, two qualities essential to scientific progress. In either case, the image and its claims have already accomplished something valuable. They have sparked global curiosity, encouraged scrutiny, and highlighted the fragile boundary between what we think we know and what remains hidden in the darkness, waiting for the right instrument or the right enhancement to reveal itself.